Right, so this is me. That's some details about how you can get in touch if you decide you want to. I also wrote a couple of books, which one of them is still relevant if anybody's interested in learning more about me. So the talk that I wanted to do today was about CI/CD, database and zombies. So the obvious question is, why zombies? But nobody asks.
Why zombies?
So I was talking, obviously I had the original title, CI/CD and databases, and I asked a friend of mine, and I've got a bit of a reputation for like cooking dry chicken, and they suggested it needs a bit of zombie gravy to make it less dry, because I don't know, I mean, to me, CI/CD and databases is exciting enough, but there's zombies in this, so feel free to shout out when you see a zombie, because there are some zombies, courtesy of Dali, because I can't draw, dotted throughout the talk. Okay, so CI/CD. Who uses CI/CD? Cool. Does everybody know what CI/CD is? Does anybody not? Okay, cool. So CI/CD, there's other benefits of using CI/CD, but they're some that just occurred to me while I was sort of sketching this out. So for your software, you probably already do this. Does anybody not? Okay, cool. I won't ask why. So generally, everybody accepts that's a good idea. But for databases, so does anybody use CI/CD for their database or for the database deployment? Okay, so about 3 or 4 people in the room. And not a lot of people do, so if you don't, you're not alone. But it's the same benefits, these were the same benefits, I just couldn't get out a PowerPoint to tell me to the same layout as the last one. First zombie, see, nobody spotted it. So it's the same thing, you get a faster delivery, you reduce errors, you get a consistent environment, version control, and you can test your deployments, all of them things that you don't get if you just press in F5 on like SSMS or something like that. Okay, so data deployment and migration strategy for schema changes. So I split this. Yep, that's another zombie. I split this into, I actually typed into Dali something like a zombie eating a database, and it came up with these bizarre pictures that are slightly disturbing. So I split it into sort of 3 main sections, because there's obviously schema changes that you've got to consider, but there's also data changes that I think fewer people consider. And then there's things like testing and so on that I've covered at the end. Right, okay, so here's the problem. If without using CI/CD or some mechanism of automating your database deployment, you can't track what has been done to the database. You can't track who's made the change or what they've done to it. You can't synchronize between the deployment and the software that you deploy, or it's difficult to synchronize. So typically what you'll find is that you'll deploy the software, and then somebody will time it, run onto the editor window, whatever. So if you've got if your Oracle, it's Toad. If SQL Server, it's SMS. You run onto it, press F5, hope that works, because otherwise the software you've just deployed might break the whole thing. You've got a reliance on a small group of people to change a database. Does anybody have DBAs in their organisation? 1.5 people. I don't know what half a DBA looks like. So if you've got DBAs and they're the only people who can change a database, and they're the people who press F5, then you've obviously got a dependency on them, and queues can build up. And then this last one. So has anybody not been on a production database and ran something that when they thought they were on their local database or a staging database? You haven't ever done that?
Oh, sorry, for a second.
Everybody else has. yeah, so I've done it. I think a lot of people have. If you've got access to the live database, then that's a bad position to be in. Okay, so migration techniques. The first one I think is probably the most important about coupling software and database changes. This is what I sort of started with. So if you've got a change to your software and it relies on the database, and those two need to be deployed at the same time, then you've got a synchronization problem because the actual change to the database needs to go out at the same time, otherwise it could break. We'll talk a bit about how you could mitigate that, but broadly speaking, that's true. So if you add a new field, for example, and you're writing to that new field, which you typically might, because that's why you've added the field, and the field doesn't get created in time, then you write into a field that doesn't there and you start getting errors. And then obviously there's you've got your consideration of a test environment or a staging environment, whatever you want to call it. You should really be able to run changes on any target environment, and you should be able to bring that. So if you wanted to run your changes locally, you should be able to do that. If you want to run them on a staging environment, if you want to spin up a staging 2 environment, that should also be possible. Okay, so these are some techniques about ways of mitigating that synchronization problem. So this situation is probably the most simple and probably the easiest to deal with. So you want to add a new field. You've got 3 fields, you add field 4, so that's quite easy. Again, unless you write into field 4, in which case there's a consideration there. But this is the harder problem where you've got you want to change one of the fields or you want to remove one of the fields, whatever it is. But if we just focus on changing one of the fields, because that kind of covers a lot of the problems that you face. So if you just run that change, if you say I want to update field 3 to field A, that will probably work, and your software may or may not work with it. If the database change gets deployed in synchronization with the software update, that might work. A better way of doing it is the process of adding the new field. And I think you know where I'm going to go here. You add the new field, and then you copy over from the existing field to the new field, set up some kind of a strategy to copy, and then you get rid of the existing field. Nobody spotted the zombie. Really, really big, colourful zombie. Nobody spotted it. Then you get rid of the existing field, and then you've sort of changed it over. But it's a 3 or 4 stage process depending on when you deploy your software. Okay, so these are some of the deployment techniques that you can use. This concept of what's sort of so-called blue-green deployment. So this gives you the chance to maintain. The idea is that you basically maintain 2 environments for whatever period of time that is, and then you switch over to the new environment, so you have minimal downtime. That is particularly useful, and a lot of software does that now out of the box. So if you want to do a big change to a table or something like that, what it'll do for you, and what you can do yourself, is create a second table with the changes, copy over the delta, and then get rid of the first table and just rename it, which is a quick process. So it's good for like time-consuming updates. Obviously, you need to make sure that the scheme is the same, and kind of goes without saying. And then you need to sort of take care of the delta, which can be a little bit more difficult. And the other deployment technique is this feature toggles, which you can't really have a feature toggle on a database as such. I mean, you might be able to do some fancy stuff with stored procedures, but I'm not sure that necessarily fits in the criteria. But it does mean you can write software that you deploy but don't actually release until you're ready with the database. So you can sort of have software that updates the new field that we spoke about, and then release kind of at your leisure. Right, okay. So migration approaches. So these are the ones that I could sort of think of as I was writing this talk. You've got the option of doing live updates. So having somebody log on to the live system and press F5 to run a change to the database is a valid option. It will work. There's downsides to it, but it technically will do what you want it to do. There's migration-based and state-based. So has everybody come across the difference between the two? Or has anybody not? Okay. So basically, with migration-based, you maintain a list of scripts that you want to run on the target database. And you can do that however you want. It can be one. I used to work at a place where there was a DBA and she just kept a huge list of everything that's ever happened to that database since day one. Every single statement on it was idempotent, so it could be run again and again. But she had to maintain that list, and it was just one script. It was thousands and thousands of lines long. It was absolutely unmaintainable, and only one person understood it. So you can do that. That's migration-based. You can also have individual migration scripts. So you can say, I want to create a table, that's one migration script. I want to add a field, that's the next migration script. With state-based, what you do is you say, here is the thing that I want my database to look like. Here is what my database looks like. And then you go to some tool, which we'll go to in a bit, and that'll say, okay, here's how you get from A to B. And then there's kind of a hybrid approach where you can do a little from column A and a little from column B, which in some cases is preferable. Okay, so live updates. The downsides, you don't have a lot of control over what you're doing. Obviously you do have control in that, you don't have to press F5, but if people have got access to the live database, then you haven't necessarily got any jurisdiction over what they do on the live database. So if they've had a couple of whiskies on a Friday night and they log onto the live database and drop your entire production system, sad luck. There's very little traceability, so if they've done that, you won't know they've done it. Somebody's done it at that time of night. If they're the only person with access, then you might be able to work it out, but there's not much to say this person dropped this table, which is bad in most cases, but if you're storing financial data, that could actually be illegal. And I imagine there's other cases where it's probably not legal to start deleting data. There's obviously a chance of possible mistakes. So if like I said, the guy who logs on at whatever it is 3 a.m, he's had a few whiskies. He probably doesn't intend to do what he's doing, but he might drop the database by accident. And synchronization. So it's very, very difficult to maintain any kind of synchronization between environments if somebody's just logging on and doing the change they want, because typically they'll update the environment they need it to be updated for. So if they're doing it on their local database, they'll do it on the local database. If they then go to production, they'll do it on production. Staging might just get left behind. Or worse, a different update gets done on staging because they know that such and such a thing and such a thing is already different, and then the two start to diverge quite rapidly and drastically. Okay, so migration based. How would you do migration? So I sort of covered this a little bit, but you basically maintain one or more scripts, and that gets run on the target database. If you do the single script, it's almost impossible to do that unless you've got one person who administers that. And then, like I said, the scripts really need to be idempotent. With some of the tools, I've put a link at the bottom to a blog post that I wrote on this, but with some of the tools, they will take care of the idempotency for you. So they'll not take care of the idempotency. They will maintain a log of scripts that are run, and they will only run that script if it hasn't been run, which works fine as long as it works fine. But as soon as it doesn't work fine and you need to rerun it, then you're in trouble. So it tends to be a good idea to keep them idempotent. And yeah, like I said, there's tools that help. A DBUp is one, but I mean, you could argue that Entity Framework was a migration-based tool. There's Flyway, I think, from Redgate, and a number of others depending on the environment you use and the language you use. That didn't move. I need to get one of them clickers. I used to have a clicker, and there's parts of it in my bag. I don't know what happened to the other parts of it. All right, so migration-based, why? The advantages are you can track changes to the database over time, so you can see how it's changed and what's happened to it. You get precise control over each specific change, so you can go in and you can make sure that, for example, if you wanted to change an index or a stored procedure or whatever it was, you get kind of fine-grained control over exactly what that does. And it can, if you choose it to, include both data changes and schema changes. We're only talking about schema changes just at the minute, but you can actually, in that, have, I don't know, I want to delete 3 million customer records or whatever as part of that migration, as well as the schema changes. Disadvantages, so you can't see when the DB's been changed outside of the process. This is a pretty big one. If somebody goes onto the database who has access to it and changes it, your script will not know that, and so will just continue to run. So best case scenario, your script will crash because somebody's changed the database. Worst case scenario, your script will actually work and you won't know that somebody's changed the database. And it can be difficult to realign them as well. So if you have that situation and it starts to diverge, it can be difficult to get back into alignment, and you tend to have to go to a state-based tool to do a comparison. The scripts need to be idempotent, really, which can make them difficult to create. So obviously, certain things are easy to do idempotently. So if create table if not exists or whatever. Certain things are less easy, so if you're trying to create an index or a column or something, it can be a bit of a pain. And also enforcing idempotency is difficult unless you've got some kind of test that actually runs these things over and over again. And then you've got the problem of sort of almost the downside of source control, which is that once your script has been run anywhere, you can't revert it because it's already in a state where it's been applied to certain environments but not others. So you can only fix forward. So if you make a typing mistake or whatever, if it actually runs and doesn't crash on any environment, you have to fix forward. You can't roll back, which can be a pain. Okay, so state-based. The idea behind here is that you run a comparison tool. Like I said, it basically gets the desired state and the existing state. There's some examples down there. So has anybody used SQL Server data tools? I think that's possibly the best tool that you might never have heard of if you use SQL Server. So it's free out of the box and it does an absolutely amazing job. You can run it on the command line. It analyzes the state of your existing database. It analyzes the state of your target database, which can be a SQL Server project in Visual Studio. And it'll just generate a migration script to get from one to the other. And like I say, it's out of the box. Redgate are the other obvious players in that market. So they make a various set of tools. SQL Compare, MySQL Compare. They claim that Flyway does that, but I've never seen any evidence that Flyway is state-based. The script is then generated, so then it can create you a script to move from one to the other, or you can just have it apply that directly, and then you can run the script on the database. Obviously, you can do that inside of a pipeline. You can put stages where you can say, I can review this migration before it deploys. Okay. There we go. Okay, so advantages and disadvantages of that. You can, another zombie. Nobody's noticing these zombies. You can deal with them or highlight unknown changes to the schema. So if the person that we've just been discussing who made a change to the schema and shouldn't have done, has logged onto the database and I don't know, created a table or whatever it is, or dropped a table, as soon as you run a state-based comparison, it will say that isn't in your desired state, so I'm going to drop it, and it'll be obvious that that's been added. And dropping it might be the right tool, because if you keep on dropping tables that people keep on creating, they'll stop creating them. Obviously, the other option is to just remove their access so they can't create the tables in the first place. But you maintain a description of what a database should look like. So, like I said, for I think data tools is probably the best example I've seen of this, where you actually have a project and it's got like an actual description of the database in there. So that works really well. And it applies to a specific instance of the database. You might have noticed that I've put that in both columns because I think it's both good and bad. So it applies to a specific instance of the database because it's obviously targeted to the source, so you run it against what your database looks like and what you want it to look like. If you run it on a database that looks differently, that script will probably fail. So that's kind of a good thing, because your database should be consistent across environments, but it's also a bad thing because your database is unlikely to be consistent across environments. Disadvantages, it can be difficult to get a specific change in because you're just describing what you want it to look like, so it'll actually write the script that gets it there. You can normally get around that. Most of the tools have some kind of a manual override, if you like, so you can edit the script. Data migration, we'll come into that soon, but that can be difficult. Again, most of the tools have little bits where you can say, actually, I want to insert 5 rows into this table. I've got a slide later on with Entity Framework where it does that. It might not be exactly how you want it to apply, so it's if that's a concern, then you should probably think about that. All right, cool. And then we've done applies to a specific instance of the database. Okay, hybrid. So this is, there's a couple of ways you can do this in a hybrid way. Obviously, the state-based version actually generates your migration script. So that in itself is sort of hybrid if you store the migration script. Obviously, if you bin the migration script, it's not, it's just state-based. But if you store the migration script, then you can see what's actually run on the database. And in that case, it's like a 2-stage deployment. You can do migration-based, but then have some kind of a comparison. So you can, for example, have a tool that runs your migration, and then you can have some kind of process where either somebody or something, so maybe once a month it runs a comparison and says, yes, this looked like I thought it looked like, or no, you've got some problems, go and fix them. And I put Entity Framework in here because it is a migration-based tool, but it does maintain our state. The state isn't the state of the database, the state is the state of the code that generates the database, but it is still a state, so it arguably could be considered hybrid. Who uses Entity Framework, by the way? Oh, okay. That's surprisingly low figure for... all right, tools and examples. So we've discussed Entity Framework. DBUp is like a little tool I think Octopus created, I can't remember. It's like the lightest of lightweight things that just run, basically just, you give it a list of scripts, it'll run them, that's it. Flyware we discussed. Why did I make the icon of that a chicken? I can't remember. There must have been a reason. Flyware, of course, yeah, because it's chicken, you don't fly. Redgate SQL Compare, and there's versions of every flavour of the database. So I think they've got an Oracle Compare, MySQL Compare, all that kind of stuff, and SQL Server Data Tool we've already talked about. There's dozens of others. There's every language has got its own version as well. Okay, so I imagine the 3 or 4 people Yeah. The 3 or 4 people that said that they use Entity Framework will recognise this. If you don't, basically Entity Framework has a relatively simple process where you basically you attach essentially a DB context to it, and you point it at a series of classes, and it converts those classes into database tables and sort of structure. And it does it by using these migrations. So you add a migration and it'll create this for you. So this is generated code, which you can change if you choose, and then you can run them migrations, and it'll change the database for you. Obviously, the downside there is it's good in that it's hybrid, but it maintains a state. So if its version of the state is wrong, so if you change the database on the without telling it, or you can kind of get this into a state where it thinks it's catered for your changes, but it hasn't, because you've changed the code without it knowing. Then it can get confused, and when it gets confused, it can be quite hard to unconfuse it. It does have a particularly good advantage, which most migration tools don't, which is this. So you can basically move from one Entity Framework state to another Entity Framework state, and it'll just run up and down because it knows how to get back to the previous state. Not 100% of the time that works, but say about 90% of the time that works. Okay, DBUp, this was the tool I was talking about, really lightweight script sort of idea, but it's there's dozens of versions, like slightly different versions of it that are knocking about on GitHub. Again, this is just like a console app that just runs the scripts, but you can change it kind of yourself. But it basically just goes and gets a list of scripts that are in your, you can give it a folder, say all my scripts are here. It'll get the scripts and then just run them one after the other as it runs, and you can put that in your pipeline, so you can create that as a little console app, put it in a pipeline, and then just run it in the pipeline. Okay, and this is talking about SQL Server data tools. So this is like a little sort of project that I created here. It's just got a couple of tables in it, and then you can use just a sort of wizard to deploy it, or you can do it on a command line, which is probably preferable. And it'll generate a script. So there, it generates a script called database.sql, whatever, you can call it whatever you want, which looks a bit like this. It's worth noting that this is not idempotent, so it generates it in that way because it's designed to be a throwaway script. So you run it and then you just get rid of the script. So that's not necessarily the best state if you're keeping the scripts, especially. But it is quite powerful, especially if you've got a really small project or something like that. You can just have that, and it'll change the database as and when you need it to, and you can almost forget about having an actual database and just maintain it all through VS Code or Visual Studio or whatever.
I find that quite good as well, because you can run it on snapshot as well. If you just snapshot the schema.
Yes, yeah, you can, yeah.
Snapshot. Which handy, so you don't actually need the database.
Yeah, that's true.
That you want to target.
All right, the next stage, more zombies. Okay, so this is for data changes. So this is your unenviable situation where you end up with one of these kind of things. Has anybody here had the bad luck to be approached by somebody in your company and they say, our data is wrong, or our data is broken and we need you to change that data to be correct? Which is really, really dodgy in any circumstance. That's dodgy because it's well, like I said before, in certain cases it's illegal, but it's not a good situation to be in. So these are they're not the only. So there's times when you actually need to change data, but your app isn't there yet. So I don't know, you've not built in a particular feature to do something, so you have to change the data. There's a bug which breaks the data, you've got to fix that, which is the data correction. The data fixes I've put because sometimes the data might be in a state that is correct in terms of it's internally consistent, but it might not be in the state that the person who's using that data wants it to be in, which is, like I say, it's a bit of a grey area that. One-off updates, so I don't know, GDPR for example, you want to anonymise 1,000 customer records, or somebody rings up and says I've got the right to be forgotten or whatever it is. Probably shouldn't be how you deal with that, but it is a way of dealing with it. And the other thing is you balk to deployment and you need to get it rolled back. That might be another reason that you've got to basically change the data. Zombie. All right, again, so techniques for data changes. I put you can't use state-based. It's not strictly true. You kind of can. You can override some of these state-based migrations and tell them actually you need to start inserting data and so on. But it typically uses, a bit like Entity Framework does, it'll treat that data as being part of the structure, almost like structure of the database. So it works for what you might call static data, like lookup tables and so on. But it doesn't work as well in the case where you've got, I don't know, record 456 needs to be a 3 instead of a 4. Although it will, it kind of clutters up your definition with a load of crap. Okay, so that's one. The migration tool, talked about Entity Framework and DB up and so on. And then obviously you have got the option to create a script, run it manually, and then just check that into source control and say I ran this script at this date. It's probably not ideal, but it is an option. There we go. Okay. So if you're doing that in Entity Framework, it might look a bit like this. There's some program I've been messing about with, some tags for it. So it's just that's a way you can insert data into the table. But like I say, it feels a lot more like that becomes part of the structure of the database rather than a sort of ad hoc change. There we go. Okay, so we talked about manual. You can obviously run these things manually. So a reason, especially for data changes, it's probably less of an unwise thing because that by definition they're going to be non-typical. If you are doing it manually, though, I'd probably suggest that you actually source control the changes that you make, just in case anybody comes and says, "What did you do on this date?" You can run it through a pipeline, which we've kind of discussed. Usually have a multi-stage pipeline, so it's got stages of approval. That tends to make people feel safer and be safer because it doesn't just run and update your database while you're not looking. And there's the option of update on first run. This is the kind of the thing that Entity Framework introduced, where you basically can say, the first time I run this software, I want you to go and migrate to the latest version. Which has a number of advantages. It does kind of get rid of that synchronization problem because as soon as it runs the first time, it will go and sort out your database. The only downside is that it can take time to do that. So I don't know if anybody who has used the 2 or 3 people who've used Entity Framework have noticed this, but the first time you run it, half the time your website becomes unresponsive for about, 30 seconds or something while it's sorting itself out. And sometimes you even have to restart it because it gets itself into kind of a bit of a mess. But I suspect that's one day, maybe in 5 years, that'll be how all database migrations are done when we get the technology caught up. Okay, so testing strategies. So this is because when I was writing this, I thought, well, you can't really give a talk about CI/CD on anything without talking about testing, because it's kind of part of the CI/CD ethos. But then you've got to worry about, well, what exactly are you testing in a database? Because if you're running something like SQL Server, if you find that what you're testing is SQL Server, then you're probably wasting your time. Or at least if you're not wasting your time, you're working for Microsoft. So the first question you should ask is, why are you testing the database? What are you trying to prove that the database does or doesn't do? You probably don't want to be testing really basic things like, is this table going to accept the value that I put into it? Because I think any of the big modern databases are going to do that, and it seems a bit ridiculous to test it. But what kind of testing makes sense? Well, you've got these are the sort of broad categories of testing. You've got unit, integration, end-to-end, soak, and load testing. But like I said, don't test the database engine, and probably don't test anything that you can test in the code. So I think most people these days accept that you probably shouldn't be putting business logic in your database. So if the business logic in the code, there's no reason really to be testing the database if you can help it. That said, I'm well aware from painful experience that is not always possible. So I suppose what do we call unit testing? I put it in inverted commas because I don't think it's an understood term in context of database. But I mean, yeah, there's three mechanisms that you might use. One's execute and roll back. So I've used this in the past where you've got something like a stored procedure. It's got business logic in it. You can execute that stored procedure on the database and inside of a transaction, then you can roll it back. But before you roll it back, you can test what that stored procedure did as part of that transaction. Again, it's not advisable to be in that state, but if you're in that state, it's one possible thing that you can do. You can use in-memory tests. So things like Entity Framework have an in-memory version of their database, which you can use to test. They're not, the thing to remember about them, they work fine in certain circumstances, but they are not the database engine that you're testing. They're a replica of the database engine that you're testing. So if you're inserting and reading back data, it'll probably do the same thing. In fact, I'm sure it will. But it's not guaranteed to be the same because you're not actually testing that same thing. And like I said, just be careful that you don't end up doing Microsoft or Oracle's job for them and testing the database engine, because they have people to do that for. Like, that's what you pay them for. Okay, so integration and end-to-end testing. This is integration and end-to-end testing of the software that the database is using. It's not integration and end-to-end testing of the database itself. But to do a proper one of either of them tests, you really do need either the database or something mimicking the database to make it a proper test. Certainly for an end-to-end test, it's not really an end-to-end test if you've not got a version like the actual database. But for an integration test, then maybe you could substitute. It depends on what it does. So one option is to create a new instance each time. I think somebody on this meetup has done a talk on this in the past. It may or may not be Kev. Basically, you can create a new instance. You can spin up, SQL Server, MySQL, whatever in Docker. You get a fresh test each time. Obviously, the downside of it is that it doesn't represent realistic volume. So, if you spin up 1 million records then you've only got 1 million records on that database, and that might not be heavy for that database. So you might have a database that's been running for 10 years and it's been inserting 1 million records a day. So if you run it with 1 million records, you're not really testing it properly. And the database state is always clean, which is an advantage and a disadvantage. It means you don't get any false errors in terms of the database, some stray data that kills your test. But the downside is you don't get any stray data that kills your test. And then the other option is connecting to a dedicated test database. So this is, you have a database that's sort of sat there, and its sole purpose is to function as your test database. The sort of downside there is when you finish with it, you've got to leave it in a state that it can be reusable. So I don't know, if you're creating sales orders, and then I don't know, you do something to the state of the customer that you use, and then that customer's blocked. The next time the test will run, it'll fail, but it won't fail because there's anything wrong with the software. It'll fail because it's supposed to. And you can also end up with an additional, well, you absolutely will end up with an additional database to maintain, because it will become a version of a test database. Again, not necessarily a bad thing, but it's worth bearing in mind. There we go. Soak testing. Who has a soak tested or soak test environment that they run all the time to check that their software does what it's supposed to do over a period of time? Like one person nodded their head there, so I'm in completely virgin territory. All right, so basically the idea is that you run a sort of low level.
Production count.
Say again, sorry?
Does production count?
I think it probably does, as long as you don't use that part of the. I've seen that before, where people have a part of the production database, and that's like their soak test. But it's sort of valid if you split a database in two and say this part's for testing and this part's for live. It might not be advisable, but. So this is basically, you connect to a dedicated test environment. Again, you've got to leave it in a reusable state. You've got to maintain it. It costs money, but you've got an environment that's kind of in a permanent live-like state, which is an advantage. And the other option is you connect to a staging and test environment that's already there. But if you have dedicated manual testers, does anybody still have dedicated manual testers? 3 people put the hand up there. That's interesting. If you have dedicated manual testers and you start running automated tests on their environment, they may or may not shout at you. They probably should shout at you, but they may or may not. Zombie! Okay, so load testing. I put what does this mean, because I think it's probably not clear what it means. If you're load testing a database, then you're definitely testing the database infrastructure, so you shouldn't do that. If you're load testing your application, then why would that be slow into the database? It probably means you've got some business logic there. So I think that the time that this sort of makes sense is the end-to-end situation where you've got a test that runs all the way through. It puts stuff in your database, and you just want to see what happens when you put 100 million records in your database as part of this test and what the software does. But just inserting 100 million records into a MySQL database or a SQLite database or whatever database you're using isn't really going to prove anything. And that is all I've got. There's some links here. That's an article on blue-green deployment that I thought was quite good. That was the article I referenced before that I'd written about DBUp. And a little tool I've been playing about with that I wrote which basically allows you to collate list of resources. So I put the list of resources from here in that tool. Any questions? Cool. Oh, go on.
I've got one. So say you've got like some tables with trillions of records in them, and you want to add like an index, and the system from like, I don't know, 8 till 10 at night is always just getting hammered constantly all the time. You don't want to just run that index to be created in the middle of the daytime. Do you schedule it to be done at 3 o'clock in the morning when nobody's around, or what do you do then?
Potentially, but the thing I was talking about with blue-green, we recently had a similar sort of situation where we were concerned that changing an index would take down the database for that reason. And we used that technique of blue-green deployment. We actually used a tool, which I can't remember the name of it now for MySQL, it does it for you, but basically it does that. So it creates a separate table, copies all the records into it, so you're not actually losing any deployment, you're not losing any performance. Does all the changes on there, maintains the delta, and then all it then does is just renames, like deletes and renames, and then you've basically got your new table. But yeah, I mean, obviously, you've got to consider when your busy times are. So.
What was it called? Ghost?
Say again?
What was it called? Ghost? The tool?
No, it wasn't. You know what? When I sit down, I'll remember it immediately. But yeah, it's going to kill me now. But yeah, it's only for MySQL as far as I know. But it does do a very, very. I'm guessing this is just a different version of it. So.
That's like a GitHub tool, which sounds pretty much what it's like.
Yeah.
I think.
Yeah, so a follow-up question. Copying trillions data is a bit costly, right?
Say again, sorry?
Is that the right approach to do so? So if you're trying to copy a trillion data,
Yep.
The approach that you told, you were using a tool where you copied the entire table and the data also.
Yeah.
Isn't that too costly? Is there a better way to do it?
Well, it is. I mean, it takes a lot longer than just changing the index because you're building up a whole new table, but you're building up a whole new table that nobody's using. So you've got, I don't know, your sales order table and you've got 1 trillion records in it, and now you've got a new sales order table, and it might take a day to build a new sales order table, but nobody cares because nobody's looking at the new one. And then the only thing that you actually care about is just at the very end, where you go delete this, rename that. So it's like a sleight of hand, really. It's like it might take a day, it might take 2 days, it might take a week, but nobody cares because it's all happening in the background. So and then just at the end, you just switch it over.
I suppose you can throttle that as well.
Yeah.
So it's not impacting.
Yeah, so you can sort of play around with it. Pacona, just remember the name of it, Pacona. Any other questions? Cool. Thank you, everyone.